Hello everyone, today we'll talk about the problem Grumpy Bookstore Owner. We have a bookstore that's open for n minutes. On each minute, some specific number of customers come into the store and they leave after that minute. We want those customers to be satisfied. However, the bookstore owner is sometimes grumpy, so for every minute we know if he's grumpy or not. If at a given minute he's not grumpy, then all the customers from that minute will be satisfied. If he's grumpy, none of them will be satisfied. So what can we do? We can select some minutes, consecutive minutes. So we're given a number and we can select that number of consecutive minutes. And during that time, the bookstore owner will never be grumpy. So we can make sure that for some consecutive minutes, for the number that we're given, he's not grumpy. So all the customers that come into the shop in that interval of minutes will be satisfied. And of course we want to maximize the total number of satisfied customers. So how do we approach this problem? Well, first of all, we know that all the customers that will come when our bookstore owner is not grumpy will always be satisfied. So we can forget about them. And now we're only left with those who are not satisfied, because the bookstore owner is grumpy when they come into the shop. So now we want to select in our array customers this interval where the sum of all the numbers on positions where, of course, the bookstore owner is grumpy is maximum. Because then for all of those customers, they weren't satisfied before and they will be satisfied when we select that interval. So how do we do it? Well, we can use a simple method called sliding window. Let's say that we look at the first minutes, consecutive minutes. So we will just sum up all the customers there that are unsatisfied at the beginning. And maybe this is the best that we can do. So we will remember it as the best that we can do. And now we want to look at all the other possibilities. So let's say that we move 1 minute to the right. What does that mean? So in essence, if we look here at some block, and we know the sum here, then we want to consider the next one. So consider this one. Then this one will be added and this one will be subtracted. Right? So if our bookstore owner was grumpy on first day, then all those people will not be satisfied when we move this interval to the right. However, if the bookstore owner was grumpy at this minute, then all of those will be satisfied. And the rest doesn't change. So we can update our sum in just two positions. This position that we lose and this position that we gain. And you can keep on doing that. So another step, subtract this, add this, and so on. So we will look at all the possible consecutive intervals of length minutes. One of those is obviously the best one. So we will find that best one. And the idea here is, of course, that by doing it as a sliding window, for every element we add it to an interval once, and we also remove it from an interval at most once, which means that this takes linear time with respect to the number of minutes. And this is our code. This is all the people that are satisfied no matter what. So essentially we just take all the grumpy and customers values for every minute, and if we're grumpy then 0, otherwise C. We sum those values, and these are all the customers that will be satisfied no matter what. So they will be added to the result. And now we just look at the current sum in our window, the best sum in our window, and we add the next customer. So the number of customers at minute I, assuming that we're grumpy, so we can just multiply by the value grumpy, since grumpy is either 1 or 0. This is a standard Boolean value. And also maybe we have to now subtract the part on the left, so we do so. So this is the same as here, but with a minus. And of course we have to remember the best of all the windows. Now in this case I also consider windows like this one, this one, this one, but of course it doesn't change the result. And of course at the end we have to return the sum of those that were satisfied all the time and of those that can be satisfied with just one use of our secret power.